countries on which we're gathered and pay my respects to their elders past and present. In particular, I acknowledge the Camaragal people of the Eora Nation on whose traditional lands I'm speaking from. My name is Jennifer Lang, and as I'm chair of the Actuaries Institute's COVID-19 working group, I'll be your facilitator today. I'm very privileged to be introducing our speaker today, one of Australia's national treasures, Professor Peter Doherty. Professor Peter Doherty shared the Nobel Prize in Physiology in 1996 with Swiss colleague Rolf Zinker-Nagel for their discoveries on how the immune system recognises virus-infected cells. He was Australian of the Year in 1997 and has since then, as well as continuing to be active in science and research, has gone into bat for evidence-based reality relating to areas as diverse as childhood vaccination, global hunger, and anthropogenic climate change. He's still active in science and involved in large grant-funded programs. In non-pandemic times, he commutes between St Jude's Children's Research Hospital in Memphis and the Doherty Institute in Melbourne, where he now spends most of his time. As well as his published reviews and research papers, he's the author of several books for non-scientists, including from 2013, one called Pandemics, What Everyone Needs to Know. His current focus is increasingly on public communication of science and on defending an evidence-based view of the world. So before I start, if you've got any questions you'd like me to ask Professor Doherty, please use the Q&A button at the bottom of your screen, and then let's get started. So Professor Doherty, welcome to the Actuaries Institute Summit. It's an honour to have you here.
Pleasure to be here.
So I'll start by just asking you about the coronavirus. Get straight into it. You're the expert. What kind of virus is it, and how has it managed to wreak so much havoc across the world?
Well, it's what we call an RNA virus. All our genetic material down to the bacteria is in DNA, but viruses, either DNA or RNA, that's how it gets its information across. And like all viruses, what it is some nasty genetic information packaged in protein and lipid and a bit of sugar. And its whole aim is to get from cell to cell, because like every virus, it can only replicate in living cells. It can't multiply by itself like bacteria can, or some bacteria can. So its whole strategy is to try and infect other people, other individuals, other whatever. And it's a virus. This virus, we think, comes from bats. There's a number of these things in bats, and we've had 2 of them come out so far before this one, the SARS-CoV-1 virus in 2001, 2002, and the MERS virus in about 2012-13. So we've had kind of a warning, and now this one. And it's a big virus for an RNA virus. It's about 30,000 base pairs, doesn't mutate a lot, totally new to us. Called a coronavirus because the protein on the surface of the virus, which was first seen by British electron microscopist June Almeida back in the 1960s, who named these viruses, looks like a crown. And we've had 4 of them circulating in humans up till now, all common cold viruses. And one not that different from the one that's currently causing all the problems. But this is new, and it's dangerous, and it's done a lot of things that we didn't expect it to do.
So what is it about a new virus that challenges our immune system so much? So what makes it so challenging for all of us?
Well, all virus infections, when they first happen, are new to our immune system in a sense. So we're always naive in immunological terms. But we've lived with some of these viruses for a long time, and it's pretty likely they've shaped us to some extent in our genetic makeup. And it's also very true that we've shaped them, because some of them have evolved mechanisms so they can, say, persist in us. I mean, you'll be very familiar with the cold sore viruses and the shingles virus and so forth. They persist in us, and they have various ways of kind of defeating our immune system, but not to the point where it kills us, but just where it allows them to persist. So, a totally novel virus is just an unknown quantity, and this one turned out to be much, much different from what we first thought it was. We first thought it was just like influenza, just a respiratory infection like the other human coronaviruses, but now we realize it's a much, much more dangerous beast.
Yeah, I've been reading that it's doing things to all different parts of the body that
yes,
nobody realized at the beginning.
No, well, influenza is a respiratory infection, and normally in humans, it stays in the respiratory tract. The the nose, the lungs, and so forth. And of course, it can kill us. And if it does, we tend to drown in our own lung fluids in the end. With a respiratory infection, you always die in the end from lack of oxygen. I mean, that's mostly why we die anyway. So basically, this virus, though, is causing a lot of problems in the vascular system. It's causing a lot of blood clotting problems. It's clearly getting around the body, though we can't find it in the blood, because we think when it gets into the blood, it's taken out very quickly. It's getting to the heart and the kidney and various other places. And the only way it can do that is through the blood.
So do we think that that's why there's so much comorbidity issues? So if you've got some other disease that you're more affected by it, or is that just
yes,
because you're weaker?
The comorbidity with diabetes, for instance, is probably reflecting kidney damage due to the diabetes and the fact that this virus can damage the kidneys. Comorbidity with obesity in younger people, very common in all these infections, and obesity is not a good health indicator anyway. So that's an issue. Not so much in elderly people, but I think the obesity issue there is being masked by other issues. Comorbidity with high blood pressure. Now that's more characteristic of this one, not so much for other viruses. And then of course just age and probably a failing immune system with age.
So I've been reading your blog on the Doherty Institute about the immune system. It's hard for us non-specialists or non-technical people to understand. Can you tell us a little bit more about how our immune system works and how that helps the researchers create a vaccine? Or that's probably too big, too many questions. A lot of questions in that, I imagine.
Yeah, I've been trying to simplify these little 800-word things I've been writing every week for our Setting It Straight thing on our website, the Doherty Institute website. If you want to read them, that's where they are. It's actually very hard to write 800 words, much harder to write 800 than to write 1,500, because you have to be very concise. So I've tried to keep them pretty simple, and have introduced other elements, like the latest one I think was called Love at First Sight, and the next one's about dreaming sequences. So sometimes I think this may be a path to madness. The immune system we're interested in here is particularly what we call the adaptive immune system. That's the specific part of the immune system that's relatively young in geological time. It's about 350 million years back that vertebrates started to develop this adaptive system, the bony fish actually. And there are different themes in the different vertebrates. I mean, they do the same thing, but the way it works in birds that are descendants of the dinosaurs, and in us that are, of course, mammals, is a little bit different. And it can vary in the mammals too. Camels are a bit different from us, for instance. So what this is the system which has a specific immune responsiveness and specific immune memory. And they're terms that we, of course, use also in neurological awareness, but of course, the immune system operates below the level of consciousness. What we do when we give a vaccine is we prime up that capacity to respond to an infectious pathogen, often by either killing early on, a lot of the vaccines were actually kill viruses or kill bacteria that were safe for that reason, though they did have some problems if you're giving a lot of them. Now they tend to be bits of the virus that are delivered in various ways. They're pretty safe, and though no medical intervention is always ever totally safe. So vaccines are the way we go with this, and I think that would be, from my point of view, infinitely preferable to getting the infection.
Well, from what I've read from a lot of people's perspective, I've got a question back to the virus itself. Do we know why children are thought to be less impacted by the virus? Because it's actually really unusual.
No, we don't really, and it's very interesting because children are definitely a problem with influenza. There's very good studies from Hong Kong, Ben Cowling, an epidemiologist, that showed very conclusively that that influenza is often brought into the household by children. And young children have had no prior experience of influenza. As we go through life, of course, we experience influenza over and over. That does give us some cross-reactive immunity that we still have to make specific vaccines, but we do have some immunity to it. And, but this is not happening with the COVID. It's not small children who are bringing the virus into the household. They seem to be the most resistant. I think it's a bit of a mistake to call to say children in a way, because, you know, 18-year-old year 12 students are still children, I suppose, but they're really young adults, and they're probably the same risk level.
Yeah, yeah, the high schools are clearly much more at risk than the primary schools from looking at the statistics, is yes. what I can see. So that we've got a lot of questions about vaccines. One question, any view, just generally, how do we think we're going with with developing a vaccine? What's your view on what's working, what isn't, and how successful do you think we'll get to? That's probably the bigger picture, and then lots of individual questions about vaccines after that.
Right. Well, basically, you know, they'd really kicked off in the Western world in January, and it hadn't been going along in China. So basically, I think it was about I think maybe the 12th of January, something like that. The Chinese actually released the gene sequence of the virus. Now, that was all the information that was needed for the vaccine people to start working, and they did straight away. And so we had potential vaccines within a month, a number of them, and more of them have been developed. The problem, though, with the vaccine is you absolutely have to test it for safety and efficacy before you give it to large numbers of people, especially with a virus like this, where many younger people are asymptomatic or not very severely affected. So you have to be sure it's safe and efficacious too. So it has to go through a series of trials, firstly in animals. In this virus, it's ferrets and hamsters and genetically engineered mice, and then monkeys, macaques or African greens. And then you have to go through phase 1, phase 2, phase 3 clinical trials. So that's all where the time has gone in trialing these things. Now, there are a number of human vaccines that have been through what we call, they've been through the animals, they've been shown to work in the animals. Not perfect, but they've been shown to prevent severe disease, and they've been shown to give a measure of protection with very, very high virus challenges, much higher than we would ever have as human beings. Now there are a number that have been through phase 1 clinical trials. You may have read about Novavax, for instance, that went through trial here recently in Melbourne. And phase 1 is where you give it to human beings, a relatively small number. You show that it doesn't cause any really bad side effects. May give them a sore arm, may make them feel a bit cross for a day, may make them feel a bit drowsy. I don't worry about that, because what that shows is we're actually making an immune response.
That's true.
So I'd rather take a vaccine that makes me feel a bit crap for a day than one that I don't even notice. So, so they've had a bit of that side effect, but that's nothing to worry about. And basically what's been shown, that the vaccines that have been tried, all of them so far, and they're different types, are all giving reasonable antibody responses, and it looks as though they should be protective. But of course, we can't do what we do in the animals, although we may do. There's been a lot of discussion of it, but we don't normally challenge human beings with a potentially lethal virus. So what we have to do is then give that vaccine to large numbers of people and put them out in the face of infection. So this is being done in countries where there is a high level of infection. The United States, Brazil, Iraq, and so forth. And basically it's natural virus challenge. And that's what we have to do to see, firstly, whether the virus works, and secondly, whether it's totally safe. And that's what has to be done. We're hoping we'll start to see the first results of those, what we call phase 3 trials, by October. That's what the people who made the Jenner Institute vaccine, which is one of the furthest ahead, are telling us. And those vaccines are being made already. The Jenner Institute one, the British one, is being made by AstraZeneca in large amounts. And also, I think there's at least one of the American vaccines that's being made in large amounts. And it could well be that by early next year, maybe even the end of this year, we will start to see large-scale vaccination programs starting with them. But that depends on them being safe and them showing at least 50% efficacy if they're to be approved by the American FDA, Food and Drug Administration. We have our own agency, the TGA, the Europeans have their own and so forth. And the FDA is saying it's setting the bar low because this is a pandemic and it's
the 50%.
They will accept 50% protection, and they will consider protection against severe disease, not just protection against infection. And that's a low bar for them, but they think that's acceptable as long as it's safe. And they won't be bullied into releasing it if it's not safe.
Is that something that happened with the SARS potential vaccine, wasn't it? That it passed through some of those things and it actually made people worse when they encountered the virus?
It didn't make people worse because it was never really given to people. It made some of the monkeys worse.
Oh, okay.
Some of the monkey challenge experiments. Yep. And we think we understand why, and we think it was in the vaccine formulation. So we've avoided that formulation and we've seen no bad signals from this virus in the monkeys or in mice or hamsters or ferrets. Everything's been fine. There's been no, but we were worried about a phenomenon called immune enhancement. And we haven't seen evidence of it, but we have to see what happens in people. So either we may have vaccines being rolled out at the end of this year or early next year in some countries, or we'll have a total catastrophe and we'll have to think again. But I think some vaccine formulations will work even if these early ones fall down. I mean, we're told the Russians are already on the point of rolling out a vaccine. We've heard that the Chinese are vaccinating, but we don't know the details.
Yeah, so I've got a question here. What do you think of the Russian one? But it sounds like we don't know.
I don't know anything about it. I mean, we've just seen I don't know what it is. I don't know how it's made. I don't know what phase it's at. But we've seen that the Russians are saying, well, we're more prepared to take a bit of a chance on this one. And so we'll see what happens. Maybe they'll do a lot of the experiment for us. I think there is some reluctance for vaccines in our societies. So, and I think people do want to have the perception it's safe.
That makes sense. I got a question here. Do you think it's more likely we'll get a vaccine or a successful treatment?
I think the vaccines seem to be far ahead. I'd been hoping we'd see more on specific antiviral drugs that are developed specifically to target this virus. We haven't been hearing a lot. And of course, those drugs have to go through phase 1, phase 2, phase 3 clinical trials and preclinical as well. So, but you can trial them a lot quicker because the only real concern with a drug is whether the drug itself is toxic. And then, of course, whether it works. But you can do that very much faster in a way than you can with a vaccine. The other thing we've got going, and they're well ahead of what we call monoclonal antibodies. These are being made particularly by the American Regeneron company, and they can be used as either a therapeutic, that is a treatment, or as a prophylactic to prevent. But they have to be trialed too. But again, it's like trialing a drug. Now, the problem with these generally is they will no doubt work to some extent. They may work very well, but they are very expensive products. So they'd be products that you'd see used in this sort of society, but much more difficult to use in developing countries.
So once we've got a vaccine, or maybe before we've got a vaccine, how does the manufacturing process work? I've got a lot of questions about how do you make sure we've got enough for the whole population?
Well, it depends on what facilities you've got and where you are. We have very good facilities in Australia for making a protein-based vaccine, like the one from University of Queensland that's been talked about quite a lot. The CSL company has a facility at Broadmeadows, which could make 100 million doses of that vaccine a year. And they're all prepared to do that. And I think the Australian government is prepared to pay for it, but and I'd be very surprised they're not, but I think that's on the line, but they won't start making that until there's some sort of reasonable signal that the vaccine's going to be okay. And it could be that there'll be another vaccine out there more quickly that we could grab hold of because the vaccine manufacturers will license these vaccines out to people who want to make them. But we don't have the facilities, for instance, to make an RNA vaccine, which is the American Moderna one, which is very advanced too, like the Jenner one. And there's a lot of discussion going on at the moment about how we could set that up very quickly. And I think we could. And the RNA vaccines can be made in very large amounts very quickly, in fact. So, so it's more a matter of just technology. It's engineering, basically, and not even new engineering. It's just having the right stuff in your country. And there is, of course, a basic strategy both by WHO and CEPI, who paid for the development of the University of Queensland vaccine, that these vaccines have to be made available globally. And so there's real determination there. And it's in everyone's best interest anyway, because we have to get the global economy back on track. And so the sooner we vaccinate people en masse, the better off we'll be.
So we're looking maybe back at that old day when you had to have a vaccination certificate before you could get on a plane.
Yes, quite possibly. And you know, you still do. If you go to West Africa, you've got to have that yellow vaccination certificate for yellow fever.
So I've got lots of different questions about the vaccinations. And one that I'd been thinking about recently, a group of super forecasters I read said there's a 50% chance for widely available vaccine in the US before March 2021.
I'd say that's right. I'd actually put it as better than 50%, but we won't know until we hear some of these phase 3 trial results. The Moderna RNA vaccine, I think, is going into phase 3 trial now, I think in the United States with about 30,000 people. I'd expect we'd start to hear something about that October, November. The Jenner vaccine has been in phase 3 clinical trial. This is an engineered monkey adenovirus that's been engineered to have part of the CoV-2 in it. I'd expect it's been in phase 3 trial for a while now, and they're kind of saying they expect to be telling us something about it September, October. Right. I just saw a British physician interviewed last night on the TV who was saying this. So we're all waiting, basically.
So what's your, if somebody's asked, what's a reliable source of information about all of this? There's so much information out there in the world about vaccines. There's a thing from Russia that we talked about. How do you know what's real and what's just speculation?
Well, basically, a number of sources. Obviously, we're watching the media and stuff, but our institute is a research institute and a diagnostic institute, and we have a number of highly professional people in various areas. And we're a virology immunology institute. That's what we're set up to do. And we're unique in Australia that we're a big institute, by Australian terms, about 700-800 people, that is charged with doing both diagnosis and research and also teaching. So we're half university and we're half what's called Melbourne Health. And we've got federal funding for various actions and so forth. So we do the diagnostic stuff, we do the genome sequencing stuff, all of which is part of the public health effort in our institute. So there's a lot of expertise that I can go to and ask. We're exchanging information between ourselves. We have, at the current time, it's 2 times a week strategy meeting early in the day, and we can ask questions of each other and information. And many of our people are, for instance, logging into late night webinars in the United States or Europe and getting the latest information. There are focus groups on vaccines and the virus and all sorts of things. I'm not doing that. I'm too old to be up that late, but I'm relying on my younger colleagues who are much smarter and more on the ball than I am.
So what's your advice for us who don't have those younger colleagues to rely on? How do we best sift through the masses of information to work out who's a credible source?
Yeah, it's difficult. I mean, we put information out on our website. I'd say that information that you get through the Australian Academy of Science website, or through the websites of the major institutes like the Kirby in New South Wales and so will be sound. Any of the national academies, the Royal Society, the US National Academy of Science and Academy of Medicine, the CDC in the United States has always been a great source. They're in a bit compromised because of the Trump phenomenon, but they're pretty good. Our Australian government websites are fine. And they're basically sourcing a lot of their material through contact with the Australian Academy, which is monitoring this. Chief scientist, Alan Finkel, has set up very good communication channels there. So they'll be good information. They'll be more conservative than I might be. Part of my function, I think, is to make people feel better, but I am optimistic about the vaccine. And, you know, this is not the worst thing we've ever faced. It's not as terrible the flu pandemic after World War I. It's not as terrible as World War II. It's terrible, but it's also an opportunity actually to learn and to change a lot of things. I hope we take that opportunity, though I don't have great confidence we will, because we're human beings. But hopefully we will accept some challenges and make some big changes.
One of the questions I've got is about a global collaboration for medical research. It seems to me that that's been really amazing during this process. Do you think it's worked really well? Are there things we could learn about how to better collaborate?
Absolutely. The global collaboration has been fantastic. We've adopted in biology and biomedicine an approach that's long been used in theoretical physics, maybe experimental physics too. That is pre-circulating written research papers with all the data in for people to scrutinize before they're actually peer reviewed. We didn't normally do that, but we're circulating material as soon as it's written up. Now, some of that material, people will look at it and say, really, this isn't good enough, and I'd reject this paper, but we're seeing that information. And there's an incredible exchange of information going on and reagents. We're getting great collaboration because everyone wants to see this over. And it's a major benchmark for the whole biomedical research enterprise. And also, you know, our technology is just so fantastic compared with what it has been in the past. And sharing of all this information is pretty straightforward. So it's been great. And we'll, in our research webinar that we run out of the Institute, for instance, we'll often have someone speaking from New York or from Paris or Berlin or somewhere.
Yeah, so 10 years ago, those late night webinars would not have been quite as easy to manage, I imagine.
No, we're Zooming all over the planet, basically. I mean, I'm doing Zoom stuff. I've done stuff with Russia and Poland and the United States. So I think it's an extraordinary change. And of course, I think we're all very conscious that the 21st century is a very different century from the 20th. And that there's a lot of opportunity to change and do so in very positive ways. So long as our people and our leaders have enough imagination to grasp the nettle, and that's always the issue, of course.
A few more questions on Australia in particular. Oh, actually, no, I might go to the mutation question first. So there's been a few news articles about mutations in COVID-19. You mentioned earlier it's quite stable. Is that going to impact vaccine, and what does it mean for how sick people get or how likely they are to spread? What are we seeing?
Yes, the virus that's been circulating is showing some mutations. I mean, all viruses have some mutation in them, and thinking about the virus in this the mutations in this virus, think of it like a barcode. There are little changes that allow you to code and identify a particular substrain, or what we call a subclade of virus. So we could trace all the virus that came off the Ruby Princess, for instance, because of the genomics. We knew where it went. We knew where it had come from. So that's been very useful. There's other mutations. There's one virus type that seems to have taken over. We think it may be more infectious. There's some evidence. Not everyone accepts it, and it's hard to prove. It's certainly true in a tissue culture in the lab, but it's hard to prove that it actually is more infectious out there in the community. But the fact that it has kind of taken over suggests that it is. So, but it hasn't changed in virulence. It's not a more severe disease, and we haven't seen changes around what we call the antigenic site, the receptor binding domain on the virus spike protein, that would create a problem for vaccination. There are some mutations, but this virus does have a proofreading mechanism. It's 3 times as big as HIV, which has a tremendous problem with mutations, and over twice as big as flu. Neither virus has a proofreading mechanism. They throw off mutations at an enormous rate. And flu, for instance, is mutating all the time. And of all those mutations, enormous numbers, we select maybe one that turns out to be a new outbreak or epidemic or pandemic strain. And so those mutations are not that commonly selected. Often there's a real fitness cost. The virus doesn't replicate as well if they replicate around the receptor binding site, for instance, because that means they may be less infectious. So mutation so far in the community, the virus community, has not been a major concern either to virologists or vaccinologists. That doesn't mean it won't change. It could do. If it sticks around, we might well find ourselves having to reformulate the vaccine at regular intervals, but we don't know that that's the case. It's just too short an acquaintance.
So a recent survey in the UK suggested that up to a third of the population wouldn't be willing to vaccinate themselves or take up vaccination. Is there a minimum take-up rate, and what do you think we can do to improve people's comfort with the idea? I know you've talked about vaccination in the past before we got to this, about how to get people to understand why it's important.
Yes, so that's why I've been trying to talk about evidence. You know, we have this odd phenomenon that celebrities who are celebrities for, it seems, knowing nothing, promote anti-vaccination. But basically, I mean, you can find bad stories about vaccinations. No medical procedure is ever 100% safe. But, you know, I think I'm much more at risk crossing Royal Parade near my house than I am from vaccination. I'm more likely to be killed by a bicycle than a vaccine. But how do we deal with it? It's a very difficult issue. Education. In Australia, we have pretty good compliance rates with vaccination, over 90%. And some of the information you might read about people not completing vaccinations and stuff, that can often just be, say, rural areas where it's difficult to get in and get all the shots and all that sort of thing. So though it's a very vocal minority in Australia, I don't think it's particularly big. And some time back, Michael Wooldridge in the Howard government, as health ministers, brought in legislation that said if you want to get childhood benefits, you have to vaccinate your kids. In the US, for instance, if you want to send your kids to school or to preschool, you have to vaccinate them. In many jurisdictions, it's usually a local jurisdiction rule. So I hope people will take up the vaccine. We think we need at least 60% herd immunity with this virus. We're not sure. If it's measles, you need 90% herd immunity. But we just hope that people will take up the vaccine, that they can be persuaded. And from my own point of view, I think a lot of the failure to take up vaccination is simply people do not understand how bad virus infections can be. I would infinitely rather receive 6 vaccines than get infected with this damn thing.
I have seen that Samoa, which very sadly had a measles outbreak a year or two ago, has been much more supportive of vaccinations ever since.
They had a measles outbreak because the anti-vaccination people were very vocal there, and they persuaded a lot of people not to vaccinate. And they had a measles outbreak. When the Soviet Union collapsed, we saw diphtheria and whooping cough outbreaks. But, you know, getting this across to people who write about it, people who try to write very reasonably and in a very balanced way get death threats.
Mm-hmm. A couple of questions I've got about equity. One about the vaccine generally, whether we're going to see rich countries monopolise it, but also that the virus itself seems to more disproportionately affect poorer and less poorer and less privileged people. What's your views about both of those things, and what should we do about it as a society?
Well, firstly, global equity. CEPI, which is the international organisation that's funded a number of the vaccine candidates that are going forward, not either of the most prominent ones at this stage, has it written into the agreement, in the funding agreement, that I think the vaccines won't be patented and that they will be available globally. And the University of Queensland one that I mentioned briefly, which I think is a very good vaccine on current indications, but still has to go through all its trials, is one of those vaccines. And I understand there's been an agreement between CSL and government and CEPI and so forth that we will get access to vaccine. We'll also help vaccinate the Pacific Islands and I guess New Zealand possibly if they need help as well. And but that large amounts of vaccine will be made for developing countries. And that will be true of all the CEPI vaccines. The WHO has very active policies in this. We know that some vaccines will undoubtedly be used first in their own countries to the exclusion of others, and that will be true of the United States under the Trump administration. And otherwise, I think there's a general willingness to try and get vaccines out there at low cost as widely as possible. And some of the vaccines, you can do that at enormous numbers of doses, particularly the RNA vaccines. Though we don't have the facility to make them, where you do have a facility, you can make enormous numbers of doses fast. A lot of that will be done in India, which has a wonderful track record of disseminating vaccines and drugs. Really, the drug thing started with the AIDS drugs and distributing them at very low cost. And so that's, I think, what we'll see. We'll see them going out very broadly and globally pretty fast.
So that's great that we should have a mostly cooperative international community, not just people keeping it for themselves.
Yes, and then of course the other issue of the virus being within a country being much worse in poor and marginal communities. We've seen it in Victoria. I mean, you map the current situation in Victoria. It's pretty much in the areas where you've got a lot of people at the lower end of the earning social spectrum. So, there are all sorts of issues here, at least with universal healthcare here. It's not due so much to differential availability of healthcare and access to healthcare as it is in the United States, where we've seen massively more deaths in poor Hispanic Americans and Black Americans. They're also the people who are doing a lot of the jobs that require a lot of personal contact, like bus driving and delivering stuff and selling stuff in supermarkets and so forth. But we've seen the same effect here, and I think we all understand that part of the issue is that people have gone to work when they're sick because they don't have any alternative sources of income and all the rest of it. So there, I think the governments, Victorian governments, federal government, have put in place emergency packages to try and help those people. But I think we need to think this through after the pandemic is over and have some sort of mechanism there that everyone can be guaranteed quick financial support under these types of emergency conditions. And of course, there's been this discussion out there of the universal basic income and all the rest of it. So I think we need to have those discussions seriously, but it depends really who's in political power, and one side of politics is more likely to initiate those discussions than the other. So we'll see what happens, but I think we have to be very pragmatic. As we know, the world of work in the 21st century is totally different from the world of work in, say, 1980 or even 1990. We need 21st century solutions to 21st century problems, and we have to be pragmatic and not ideological about it.
So is that one of the examples of some of the lessons we should learn from this pandemic?
I think so. I think so. The Prime Minister, for instance, who's from a political theme that really would not necessarily emphasize social equity, has been very pragmatic in this situation, and that's given him a much better general standing in the community than he had before. I mean, where he fell down a bit on the bushfires, but and of course we've also seen that in all the state jurisdictions, no matter what side of politics they're from. And all the state premiers have done a really good job. But I think state politics in Australia is much closer to the people than federal politics. Federal politics to me seems much more ideological and much more arbitrary well, we won't go on with the theme, but I think everyone understands what I'm talking about.
So what else do you think we should learn from this experience of the pandemic? It'd be a shame just to kind of go back to normal. What are the other things that...
Well, of course, I mean, the much bigger bear that's out there is climate change, as your profession is very aware. And I think the idea that we're going to sort of dig ourselves out of the economic situation here by building more fossil fuel infrastructure is really not very bright, but how we change that, I don't know. And so I would like us to be thinking much more adventurously on that front particularly. But as a scientist, what I do for a living, what I'm trained to do, I'm a research scientist, a discovery scientist, is break everything down to basics and then build it up. And so, you know, you'll have a theoretical basis and you move forward, and you may realize actually that theory really isn't very useful. So you just trash it and you start from the bottom and you start to build it up from there. That's enormously difficult to do in politics. And that's one of the reasons why people like me get so frustrated with politicians, is they won't actually look at the evidence base. That they find it very hard to do that. And of course, they surround themselves with advisors who make sure they don't do it. So particularly at the federal level. So I think we need a rethink. I think the hollowing out of public service and real expertise of first-class bureaucrats has been a major problem in this. And I think that's why we've made some of the mistakes we've made. And you can't blame one side of politics or the other for it. It's been a general theme that started with Hawke, actually. And I think it's a disaster.
So do you think that we're more likely to listen to experts now that experts have actually proved their value quite a lot in this whole process?
Let's not call them experts, I think. Just call them people who actually know what they're bloody well talking about. I mean, you guys know what you're talking about. How often do you get the finance people to actually listen to you?
We like to think occasionally.
Occasionally, yeah, that's about it in a crisis situation. So basically, I'm sure they listen to you very closely on a number of issues, but I think experts is an unfortunate word. It's basically, do you ask people who know what they're talking about, or do you ask people who don't know what they're talking about? And I think it's not hard to judge it. Now, one of the books I wrote was exactly on that, trying to tell people how you find out who's worth listening to. How do you interrogate the science literature and the more general literature around science?
Yeah, it was really interesting for me to read that, just to get a sense of, you just push a little bit harder on where this person's coming from, so that you don't get the expert on, I don't know, some exercise regime telling you about vaccination.
You've got to say, are they trying to sell something for a start? That's a fact. And but you know, we have all this nonsense out there in society. You just have to go into the local drugstore and you see all these vitamins that enhance your immune system. Well, I don't know any evidence for that. Maybe it's true, maybe it's not, but you know, it helps to have a bit of evidence. And so I think we're easily conned, and it helps to know where to look for decent information, but whether people will do that or not, I don't know.
Well, going back to some experts who did get a bit of a hammering in this process, the epidemiologists, a couple of different questions I've got from people here. First of all, just your view on suppression versus elimination, lockdown versus herd immunity. Do you have a personal view, or one that you just generally about?
Well, you know, I think the way it turns out, and the fact we've got very close to elimination in South Australia, Western Australia, Northern Territory, Queensland looks pretty good. Maybe we should have gone harder for elimination. But what happened in Victoria might still have happened with the breakout from the quarantine hotels. And so we might have suffered a lot more pain at that time and not achieved that end result. Now, the question really is, I mean, New South Wales is a classic case of suppression at work. They've done a pretty good job with this, actually. And hard for someone living in Victoria to say, but I am a Queenslander, so I can say it. And they're actually doing suppression at the moment. So it's a question of whether suppression can work. If you've got maybe 20 new cases a day, you can do contact tracing and find out where they come from and really keep a lid on it. And that seems to be happening. It does require that your community thinks seriously about social distancing and all the rest of it, but you're going to introduce a lot more normal activity. Whereas in Northern Territory, Western Australia and so forth, they can be pretty much back to normal at this stage. So the question in my mind is, it would be wonderful to have elimination, but can we achieve it in Victoria with these high case numbers? And we'll see. And at the moment, today they kicked up a little bit again. That'll happen as the line goes down. It'll go up and down. We're all familiar with that from statistics, and we'll see. We'll see how it goes. Elimination would be great, but suppression, if we can get it down far enough, we can make suppression work if people are willing to be pretty responsible.
I guess that's the trick, isn't it? Because you get a bit relaxed, and then something.
Yes, I was kind of a bit horrified when they took the controls off here after the first lockdown. Suddenly people seemed to think, well, it's over. You know, I knew it wasn't over, and anyone in the infectious disease world really knows that just for politicians to say something doesn't mean it is true. Of course, politicians don't always realise that saying it so doesn't make it so. We often see that coming out of Canberra, but we all know that the virus is out there, and we should know how to behave.
And with New Zealand having new cases yesterday,
yes, that's really surprising. You really wonder where they came from, because there is a kind of monitoring mechanism, and that is people getting sick.
Yes.
And we've got a lot of testing out there, and we can test people who are sick. So they haven't had a lot of people getting sick, and yet we have in Victoria. But that's the benchmark. Are people getting sick? And if we can manipulate this thing either by a vaccine or by drugs or by antibodies or whatever mechanism you like, so people aren't getting sick, we can stop doing this whole lockdown thing.
And my second question about the academic epidemiologist is a bit about how you present risk. So what a number of epidemiologists around the world have got a lot of criticism for projecting something terrible that was going to happen that didn't happen. And of course, it didn't happen because they projected it and people took steps. But at the same time, it could have happened. So what's your advice to people at the Doherty Institute who have suffered from this? How do you present that kind of level of possibility that might not happen? But
well, they're sophisticated people, and they're very well trained, and particularly Jodie McVernon, who you will see regularly on the TV. There's a number of epidemiologists commenting in Australia, some of them more, shall we say, attuned to this type of issue than others. Jodie was I think maybe started HIV modelling, but she came from that community, and then became she's a paediatrician by training, and then an influenza epidemiologist. And basically the initial models were based on influenza, then data that was coming out of China. And you can only, as you know, you've got a model, you have to have some database to work from. And so the models have been getting better and better refined. And basically she's and her group and the various other top epidemiologists are being asked to model different scenarios. If we do this, what happens? If we do that, what happens? And for instance, if we get a vaccine that's 50% effective, what will happen? What are the modeling things of that? So modeling is a tool. It's always a tool. And basically scientists don't run society. I mean, Winston Churchill said it, scientists should be always on tap, but never on top. I mean, society, we're a democratic country, and it's policymakers and politicians who do so. We're thankful that in this case, our politicians and our decision makers have taken the scientists' advice. We have a much greater difficulty getting them to take the advice of climate scientists, as we all understand. So basically, though, the epidemiologists put out probabilities and relative risk equations, and it's up to the public health people and then the politicians to work from there. So I think one of the problems, though, is that in society in general, there's not a good perception of the ideas of probability and relative risk. And it's surprising because, we all realize that if you wear a seatbelt in a car, sometimes you can be worse hurt in an accident, but most of the time you'll do a lot better. So people do wear seatbelts and do so willingly. But there's a whole genre of television program and so forth that depends on outrage because little Johnny can't get funding to get this wonderful drug that nobody's actually tested, but Dr. X says is great, and all this nonsense. And so, there's a whole misinformation industry that is central to the way people get information. The gossip over the back fence way.
So one of the things that I've found reading your book actually is about how tough questioning of scientists from other scientists can be. When somebody's got a new idea, it's a really tough process to kind of temper it and find out whether it's really, really good or not. How do scientists learn to deal with that level of professional skepticism without it becoming nasty?
You don't remain a scientist when you submit your beautifully written research paper that your colleagues have critiqued, and it comes back and it's been totally trashed by 3 completely anonymous reviewers, and you might try and work out who they are, why does this person hate me so much? But, hopefully they're just criticizing your data and your analysis. And so we get very used to it, actually. We get used to being told what to do by editors and by reviewers and accommodating to criticism. And usually, in fact, almost inevitably, when a paper's been through a lot of review and so forth, it gets it gets better. But we're accustomed to that. We do it in lab meetings, we do it in seminar presentation. It's an extremely critical and extremely tough environment. And you have to be a robust personality to stay in it, quite frankly. You know, I've been writing books for, trying to write for a popular audience, a broader audience. It's very challenging to do that in science. And the editors are always amazed. You know, I don't get upset. I just get back to them, make the changes. And they can't believe how compliant I am, but I'm being used to being beaten about the head with baseball bats by people in masks.
So speaking of masks, so I've got a question about whether you wear a mask when you're out and about, and I assume being in Victoria, of course you do.
Mm.
What do you think about masks generally? Should we be making them compulsory in New South Wales?
I think it'd be premature. I'd leave it to the public health people to make that decision. Masks are, they're good in the Victorian situation. I think they're great at the moment because they raise awareness. And everyone is very conscious of the fact they've got a mask on, and you can't miss it. I mean, you know, if you go for a walk, it's a much less pleasant walk with a mask on than without. And,
I have tried it. Yeah.
So I think that's good, but it's a mistake to rely on the mask. I mean, do everything that you were doing: social distancing, all the rest of it, hand washing, hand to face is still really important. Avoiding situations where you think there are too many people around, you just don't feel comfortable. So I'd just keep those things in mind. If you're going to wear a mask, it would be in crowded situations, public transport, that sort of thing. So, and I'd vary the quality of mask. If I'm going to somewhere where I think there might be a number of people around, I wear a better mask than if I'm out walking in the park. And where if you can breathe better through the mask, it means the mask's not working as well, quite frankly. And the rewashable ones are good for that, you know.
So I had a question about whether we should have our own Australian Centre for Disease Control, whether we would have had a better process. Maybe it comes back to some of your comments earlier about the public service having more expertise internally. Do you think that would have made a difference?
Yes, I think I'd been very much in favour of that idea because I was used to the American CDC model where they have a professional corps, as the United States Public Health Service is called. They actually are a commissioned corps. They wear a uniform, or they can be required to wear a uniform, like a naval uniform. I go in, I've been into labs where I'm used to seeing my colleagues dressed in jeans and a t-shirt, and they're dressed like a bloody admiral. It's very disconcerting, but they can be required to wear that. The other commissioned corps is the NOAA, the National Oceanographic and Atmospheric Administration that monitors climate change. It's also a commissioned corps. But CDC hasn't worked particularly well in this pandemic, and partly it's due to the federal administration, which is chaotic, as you know. And our system has worked reasonably well, and it's all state-based. It's been tested, and it's been reasonably good. And the committee structures that are in place, the communication mechanism in place, pretty sound. I think sometimes we think maybe communication could work a lot better and so forth. But it might be a good idea for Australia. I think it's something that really needs to do. We need to come back to after this and really look at that in detail, whether we want to do that or not. Not something we should be raising now. It's something of weight.
Yeah, I imagine there's probably a long list and we should be prioritising the ones that will make the biggest difference.
Yes, I think so. I think we need to look very closely at what we've learned here. And I think what we've learned is that if you don't treat the people at the bottom end of society a bit better, you can cause enormous economic damage, because all this economic damage we're seeing was because some people just didn't have enough security, financial security. If we can do something about that, and I think we could do it just as cheaply as we do what we do at the moment with all the different programs for helping people and so forth. If we could just get this to a different stage and stop thinking that you can only have an entrepreneurial society if you practice cruelty to the poor, I think we could move forward a lot more positively.
Do you think that's a wider lesson than just pandemics?
Oh, absolutely. It's going to be absolutely. It's, you know, we saw it in the bushfires, basically it was exactly the same problem. In fact, it still hasn't been solved, getting resources to people who need it quickly. And there's a willingness to do it, there's money committed, but it doesn't go out. Can't we work this out a hell of a lot better? Can't we work out so that everybody has some support? It's actually cheaper to have homeless people in a hotel than it is to have them on the street, because of the cost of policing, the cost of crime, and the cost of emergency medical care. So we never do zero-based budgeting. We never look at what it actually costs. And what we understand, of course, is there's a lot of the costs in society are public costs. They're public liability and private profit. And so we have a model which says private profit, public responsibility, public liability. You know, every time someone sets up a call center in India or something, that cost falls back on the public. So if we can rethink a lot of this and work out a better way to do it, not in a way that's doctrinaire or socialist or conservative or anything else, just work out what the costs are, how we can do it better, and how we can use even the same amount of money or even less to do a better job. And I think we could.
So that's not a lesson I would have expected to get from you, Pete. Zero budget.
It's what we're seeing, isn't it? I mean, the people, the virus got out of the quarantine hotels because people who had inadequate training and poor income had to work. It got spread between the aged care homes because people were working 3 jobs in different aged care homes. That should have stopped. But then there's an issue with aged care, for instance. You would be much more aware of this than I am. But how much asset can you have and still fall back on the public purse in aged care? It's not just a question for government. It's a question for us. It's a question for each and every one of us as we think about how we vote and what we think is acceptable. And so it's a personal responsibility. And government is an extension of us. I mean, we get the government we elect and the government we deserve.
I think that's one of the things that we do think of in Australia as government is working for us. And the more we do that, the more
we have to be prepared to make government work. We have to be prepared to give it the resources. You know, we've gone through this whole period with Reagan and particularly began this business of running against government. Now, government is an instrument of the people.
So I did want to come back quickly to climate change, just because I know there's a lot of people who I've talked to about this conversation that are very interested in your views on what we should be doing about climate change. And I know you spend a lot of time on it. So I'll just ask you quickly, any other lessons out of this process for climate change that we should be taking back?
I think we should be treating climate change in much the same way. It's a longer term problem. It's not something where we can switch immediately from one system to another. We all realize there has to be phase out periods and all the rest of it. But thinking that we're going to bring ourselves out of this by using public money to support fossil fuel infrastructure seems to me to be ridiculous. And this is the big problem facing us. It's going to build slowly, but it's much more dangerous than this virus. I mean, this virus is not killing that many people. And we've dealt with it and we've responded. It's horrible, it's terrible, and it's causing a lot of grief and suffering. But in the long run, what's happening with climate change could be infinitely more dangerous than this.
And a question that's actually, it's come from the pandemic side, but is also relevant for climate change. How might this change our view on individual versus society, responsibilities of individuals to the collective and vice versa?
Yes, I think, you know, there's collectivism kind of has a bad name because of the way it worked. You know, basically a lot of you had people who are just as bad as the people who had power before, who've taken control just from a different direction. And you saw what happened in Russia and all the rest of it. And there's no, the problem is authoritarian systems and the acceptance of them. We have to reject that totally. But on the other hand, you can't have anarchy. And that's essentially what the neoliberal viewpoint is. It's an anarchy viewpoint, no tax, no regulation. And what happens there, we all know perfectly well, the rich take everything. It's a disaster.
I guess I should have, instead of collective, I should have said Team New Zealand. What they've done in New Zealand, they've called themselves all members of one team, and it seems to have worked pretty well for the way of thinking.
Well, of course, you know, we have that problem in Australia. We've got all these different states.
That's true.
On the same team normally.
But
I think that's the issue. I can't see how you can have liberty without responsibility. You can't have individual liberty without individual responsibility.
So I guess we've reached our time limit. I guess one last question. I know I've asked you before, but I just wanted to ask you again. What's the one thing that you'd like us to all learn from this that we should take out to try and make Australia, all the other people from different countries, a better place?
I think the one thing we've learned from this is the one thing that you guys know anyway as actuaries, and that is you look at the evidence and you give advice and you develop protocols and policies from there. Look at the reality of it. The reality, political reality is one reality, and it's the reality politicians have to deal with. But we're actually in a situation now with an enormous population on the planet, with massive pollution problems, and of course the climate change problem, now the virus problem. We have to start looking at the realities and reacting to the realities. And of course, that's part of the job of science, is to try and tell you what the realities are. It's not just science, it's the modeling and stuff you guys do. And so if we can engage with reality and not be conned, and of course there are tremendous influences out there that depend on making vast amounts of money and so forth through doing that. So we've got to be prepared to stand up to that and see through it. And it gets down really in the end analysis to what each and every one of us do and how involved we are.
So evidence-based reality is a great lesson to finish on. So we could talk for hours, and I've got lots of questions lined up, but I think I'd keep having lots of questions if we kept going. So regretfully, I'm afraid that's all we have time for today. Professor Peter Doherty, on behalf of the Actuaries Institute, thank you so much for coming here to share your wisdom with us today. I've certainly learned a lot, and it's been a privilege to spend time with you. I'm sure the audience would join with me a round of applause, if only it wasn't virtual. So take the round of applause as read, and thank you very much. It's been a pleasure talking to you today.
Well, thank you, and be safe and be well to everyone.
You too. Thank you very much.
Bye.
Bye.